Today we're going to talk about polynomials. For a quick review, a number in front of a variable is called coefficient. If there are no numbers in front of the variable, the number 1 is understood. For example, when we say the variable x, we know that that means really 1x, where 1 is the coefficient of x. There are three types of monomials. We have numbers, such as 3, -7, and 2/3. We have variables, something like an x, y squared, or x squared, y to the fourths, where we're kind of multiplying two different variables together. Then we also have the product of numbers and one or more variables. For example, 3x would be a monomial, a number times x. We could have 4xy's. We could also have -2x squared y's. So a number and one or more variables. Notice in the chart to the right that we have some things that kind of look like monomials, but they're really not. So a monomial has to have whole number exponents. So in the case of the first one, x to the 1½ or 3/2 would not be considered a monomial because it needs to be a whole number exponent. The second one, monomials cannot have variables in the denominator. So if it has a variable in the denominator, then we would say it's not a monomial. And we also cannot have variable exponents. So 7 to the y power cannot be a monomial. The degree of a monomial is the sum of the exponents of the variables of that monomial. Well, what does that mean? So in example 1, looking at letter A, 5x squared. Well, when I look at 5x squared and I focus on just the variables, I have the second power here, which means that the degree of the number letter A is the second degree. When I look at letter B, and again I'm focusing on the exponents of the variables, notice when I look at -1/2 x y cubed, we know that there's a 1 power where the x are, which means that if I take the exponents into the sum, this is to the 4th degree. Letter C, I don't have any variables. So in this case, we would say it's to the 0 degree. Okay, it's just a way of classifying the monomials that we are looking at. Letter D, you would have the 4th degree. Letter E, again, we have C and D variables to put together, so it's to the 5th degree. 5/3 y, we all know that the y means that it's to the 1st degree, which means this whole monomial would be the 1st degree. And again, G would be to the 0 degree. A polynomial, which is the general term of these, is a monomial, so it could be 1, or the sum of monomials. Each monomial is called a term. So when you look at the two examples here, a polynomial with 2 terms is called a binomial. So the prefix bi would tell me that there are 2 terms. You'll notice that the monomial types that we have one which was the product of a number and a variable added to one that was a monomial that was just a number. A polynomial with 3 terms is called a trinomial, which again the prefix tri means 3. And again you'll notice that in this case we have the monomial with the variable combination, the number and variable product combination, and also the plain number combination. The degree of a polynomial is a little bit different than the degree of the monomial. Remember, the monomial degree is you add up all of the exponents on your variables. The degree of the polynomial, though, is the greatest degree of its terms. You will not be adding them together. All you're going to do is focus on each of the monomials separately, and the one that has the highest one, that is the degree of the entire polynomial. A polynomial in one variable is in standard form when the exponents of the terms decrease from left to right. So, for example, x to the fourth plus x to the third plus 2x squared plus 5x plus 6 would be a polynomial in standard form because I start with the highest exponent degree, which would be x to the fourth, and I decrease from the fourth power to the third power to the second power to the first power to the 0 power. So let's classify these polynomials. Write each polynomial in standard form. So we need to make sure that we are descending in our degrees. Identify the degree and classify each polynomial by the number of terms, and this is where your prefixes will come in. So looking at letter A, we have the polynomial negative 3z to the fourth power. Well, in standard form, it's already there. So negative 3z to the fourth. The degree of this monomial, because there's only one term, is to the fourth, so it's the fourth degree. The type of polynomial, it is a monomial. And again, mono stands for one. So it is a monomial. There is one term in this polynomial. Looking at letter B, we have three different terms there. So first, to put it into standard form, I need to put the exponents in descending order. So 5x squared has to go first. Then I'm subtracting the x, and then I'm adding the 4. Remember, as you are rearranging any of these expressions, the sign in front of each term stays with it. And so it's not minus 4 at the end, there's really a plus 4. So it's 5x squared minus x plus 4. Now, in this situation, we have to look at each monomial of this polynomial to decide what is the degree of the polynomial. Well, 5x squared is the highest degree. It has a second degree, so this is going to be the second degree of the polynomial. We are not adding them together like we did with the monomials. The polynomial just takes the highest degree. The type of polynomial in this case, well, we have three terms, 5x squared, negative x, and a 4. So this would be classified as a trinomial. Again, tri, like triangle, is 3. 3 terms. And then looking at letter C. So letter C, again, we don't have these in descending order yet, so we have to rewrite that q to the 5th power plus 8q to the 4th power. Oh, not 8q to the 4th power, just 8q. This would now be in standard form. So then I focus on the degree. Well, again, I look at the monomials here and I decide which one has the highest degree. And the q to the 5th power is the highest degree, so the degree is the 5th degree. Now in this case, we have two terms. Two terms is written as a binomial. And again, the prefix bi means two, like bicycle. So bisect means we're cutting something in half or in two pieces. So binomial would be two terms. Next, we're going to look at a situation where we're going to use the model that you see here, where we have the girl that is throwing a ball up in the air to help us determine the height of the baseball after the 1 second. So we are given the function that it will show us how to determine that, It is given up above within the problem as the negative 16t squared plus VO times t plus SO. Well, first we got to kind of figure out what do all these things mean in this model. Well, first of all, we are looking at this V sub O as the initial vertical velocity. So that is telling us that we are looking at how fast or how strong or how much speed are we throwing the ball with what kind of force up in the air. And notice that it's in feet per second. The second one we're looking at is the S. That is telling us that this is the initial height of the object. This means when the girl is letting go of the ball, you're going to notice here that it is at her hand level, which is 4 feet off the ground. Okay, it's not necessarily her height. It's not necessarily any specific number. It is a number that we need to get from where she let go of the ball, which was, in this case, 4 feet. And then lastly, we are told that T stands for time, and we're also told that it is in seconds. So we are first asked to write the polynomial that represents the height of the baseball in this situation. Well, when I start to do that, I'm going to see that we just fill in what we have. Well, we don't know the time yet. What we are talking about is the V, which is our velocity. We are told over here that it is 30 feet per second, so the 30 can go in where the V is. And again, we want to have the T kind of as our independent variable ready to plug in at any moment. And then the last part of our model here we have is the S, or the starting initial height. Well, we are told in this situation that we have a height of 4 feet off the ground where we let go of the ball. So now we want to determine for part B, what is the height of the baseball for after the 1 second? Well, all I have to really do is now plug in the 1 second where I see my T value, because that model is telling me what is happening as she throws the ball from the 4 feet with a velocity of the 30 feet per second. The negative 16 is actually gravity kind of pulling the ball back down to earth. So once we get the ones plugged in, we simply just follow our order of operations. 1 squared is still 1. 30 times 1 is 30. Then I can get negative 16 plus 30 plus the 4. I get 14 plus 4. And 18 feet will be where the ball is after 1 second. Now obviously, depending on what we are trying to find, we could say we want to know after 2 seconds, we want to know after 3 seconds. Whatever we want to know, we can use this model to help us figure out the situation that we are looking at. That is basically 7-1, all of the vocabulary that you really need to know for polynomials. In the next upcoming sections, we'll be talking about how we add polynomials together, how we multiply, how we subtract, and how we divide them. But this one is an important one just to make sure you understand the degrees of each of the polynomials, how to classify the polynomials, and basically what is a polynomial and how we can use it going forward.